In this video now, we are going to produce a new formula for arctan x as a power series. So arctan x or tan inverse x can be found from the integration of 1 over 1 plus x squared is right. And then you can see that under integration sign, we have 1 plus x squared to the negative 1 dx. So the power series representation of 1 plus x squared to the negative 1 can be found just from the second one you see above, that you have 1 over 1 plus x. So then this one is giving me summation with an integral sign. N goes from 0 to infinity. We'll write negative x squared to the n dx in here. Now you can separate like this. Say summation n goes from 0 to infinity. I can take negative 1 to the n and then x to the 2n will be integrating with respect to x. So simplified version, as you see here, n goes from 0 to infinity, negative 1 to the n, and x to the 2n integral will be x to the 2n plus 1 over 2n plus 1 and plus integral constant. Now you can quickly check that if I have x equals 0, so arctangent is 0. So the left side is 0. Right side we have the summation sign here. Everything goes to 0, so therefore C is 0. So in this case, you can drop C. So then the expansion for arctangent x is now summation n goes from 0 to infinity, negative 1 to the n, and the next to the 2n plus 1 over 2n plus 1. So we'll be producing our second formula. All right, for the second formula, natural log of 1 plus x, you can easily recall that the integral of 1 over 1 plus x is our natural log of x. And we are using just parentheses, understanding that 1 plus x is positive. Okay, so 1 over 1 plus x I can use as a summation. We have n goes from 0 to infinity, negative x to the n dx. So this one is simply summation n goes from 0 to infinity, negative 1 to the n, integral x to the n dx. And then you can easily check that integral of this one will be summation n goes from 0 to infinity, negative 1 to the n, and x to the n gives me now x to the n plus 1 over n plus 1. So we got our formula for natural log of 1 plus x.